All right, folks, this is going to be the last video for section 7.3. First of all, remember the Pythagorean theorem, okay? For a right triangle, a squared plus b squared equals c squared, right? Well, this section is all about the unit circle. Let's relate the Pythagorean theorem to the unit circle. Okay, draw a unit circle. Let's say you've got a point on the unit circle somewhere. It doesn't really matter where it is. For the sake of this video, let's put it over here. Okay? Over here. If you draw a ray out to that point on the unit circle, that's the angle in question is going to put us somewhere over there, right? The coordinates of this are x and y. Let's call those x and y. In this case, x is here, right? And y would be over here. What we can do is we can draw a triangle. Let's draw the triangle like this. It doesn't really matter where we draw it, as long as it has this hypotenuse of 1. Okay, we could have drawn it kind of reflected over like that diagonally. We could have drawn it on the bottom here, but I like to draw it so that it has a side corresponding with the x-axis, just for consistency. It's a right triangle and the right angle's there. This side here, the length of this side is not exactly going to be x, but it's going to be like negative x, because x is a negative number. And the length of this side is not going to be y, it's going to be negative y, but whatever. I'm just going to label these with x and y, and I'm not going to worry about the fact that those are negative numbers, because as you're going to see in a moment, it doesn't matter that they're negative. So if we take the idea of the Pythagorean theorem for a right triangle and kind of apply that to this particular right triangle, which is situated inside of this unit circle, what we get is we get x squared plus y squared equals 1 squared, right? X squared plus y squared equals 1 squared. So with that in mind, given that this is probably some angle t, right? We've got some angle t that terminates on this side here, and that the x and y values here are cosine of t and sine of t, respectively. This produces what we call the Pythagorean identity for trigonometric functions, which I'm going to write over here. The Pythagorean identity is a version of the Pythagorean theorem for trig functions that says cosine squared plus sine. Right, so Pythagorean identity, if we take the x and the y in this equation over here and replace them with cosine and sine, we get cosine squared plus sine squared equals 1. And that is an identity. That'll always be true for any angle. For any angle you want, any value of t, square the cosine value, square the sine value, add them together, and you'll always get it equal to 1. So, by the way, the reason that it doesn't matter whether x and y are positive or negative is because in the Pythagorean theorem, you end up squaring them anyway. So when you square them, it doesn't matter if they were positive or negative. They're still going to add up to 1. And another comment is the way that I've written this over here with cosine squared and sine squared. So note, that means this is like writing cosine of t and then putting parentheses around the whole thing and squaring it. Okay, so the reason we don't write it like we could, let me flip this over here. We could write cosine of t and then squared, except that is kind of confusing when you compare it to that. It's kind of not clear whether you are meant to be squaring the cosine value or squaring the cosine value would be like doing this, right? Squaring the whole cosine value versus squaring the t value. So it's like, do you mean this or do you mean that, right? It's kind of unclear, right? And especially because sometimes when people write cosine and sine, they don't put parentheses. Okay, you'll see this sometimes. You'll just see cosine t like that. And that still means the same thing, except if you put a squared here, then now it's really ambiguous. Do you mean cosine of that, or do you mean cosine of that, right? These are totally different things. This and this are very different. This and this, very different. So, to like kind of mitigate that confusion, what we do instead is you take the cosine and you put squared above the function name, and then parentheses with the input. And this is just the same as taking the cosine of t and squaring it. So in other words, it's like cosine of t times cosine of t. Okay, so I just want to make very clear what that notation means. I know it's a little weird, probably never seen it before. It's not actually common. It's not, surprisingly, it's not common to write like f squared of t. That is kind of an unusual notation. You don't see the same idea being applied with other functions, like generic functions named f. You generally don't see that. But for cosines and sines and tangents and for trig functions, you see that notation all the time. So that's the Pythagorean identity. So let's do an example of how you can use the Pythagorean identity. Let's suppose cosine of t is equal to 0.2. And t terminates in quadrant 1, which for this, saying t terminates in quadrant 1, I like to use the shorthand t is an element of quadrant 1. This is not official. I'm just saying if I do this, if I write t as an element of quadrant 1, it means like the terminal point for t is an element of quadrant 1. It's just a shorthand. It terminates in quadrant 1. So that means we're talking about an angle that ends up here somewhere, maybe over here or over here, right? Somewhere in this range. So let's take this information and use it to help us find sine of t. Okay, cosine is 0.2. Well, let's figure out what sine is. Well, we know from the Pythagorean identity that cosine squared plus sine squared equals 1. So we can write 0.2 squared plus sine squared equals 1. So sine squared is going to be 1 minus 0.2 squared, and then sine of t is going to be plus or minus the square root of 1 minus 0.2 squared. Okay? Either positive or negative, right? If you square root both sides of this equation, you get sine of t could be either positive or negative this square root. And that is plus or minus, it's approximately plus or minus 0.98. But the question is plus or minus, right? Well, since t is in quadrant 1, where sine of t must be positive, since we know the quadrant, we can say with confidence sine of t must equal positive 0.98. And we did it. Okay, so be careful with this type of problem when you're using the Pythagorean identity and you're taking a square root to solve for a value. Remember that you can get positive or negative, and whether it's positive or negative can be determined by which quadrant you know the angle is in. Without this information, we wouldn't really have been able to solve this problem because we would have said, well, it's either plus or minus 0.98, and we don't know which one because we don't know where the angle terminates. But if you remember, all students take calculus, and you remember, and you're given this information, you can figure it out.